The goal of our project is actually to create a application that classifies company into multiple industry groups using company descriptions, annual reports, and other text-based artifacts that details the business strategy and operations. The reason why we want to do that is most established classification standard only provide single label to illustrate the problem. We can see from here, the top one, Amazon, is only labeled as retailing because the larger chunk of revenue is coming from the e-commerce platform, completely ignoring AWS being the fastest growing and more profitable segment. The bottom one, General Electric, on the other hand, is giving a very vague label just because none of its 8 segments are actually dominating. So the benefit of this new approach of multi-industry group classification, we believe that better equips our investors when it comes to building a portfolio, building a diversified portfolio that generate long-term and robust growth. When it comes to data collection and processing, we use a 24 industry group as our labels that's defined in the GIGS standard. We have created 4 data sets. We consolidated from Yahoo Finance and other GIG projects in total 3,500 sample data. They're all single labels. We split that into 2. The first split 1 with roughly 3,000 single label samples. We call that data set 8. Then next, we actually use that data set 8 to train one of our target model in the phase 1 of this project. So we have that rough training model, and we actually use that model to run inference on our split 2, which is the S&P 500 data set, to generate the multi-labels. The whole goal of doing this is actually using the model to assist our labeling effort. We actually manually review all those labels to make sure they're good quality, and that's our data set B. Next, we also extracted the definition from the GIG standard. Those are their documentations. We actually put that aside, and that's our another single label data set. That's our data set C. Finally, we extracted contents from various companies' annual reports. We actually go through them and manually label them and provide multi-label as well. That's our multi-label data set D. And bottom there, as you can see, that's extracted from the Microsoft annual report, just to give an example what it looks like. Internal model software, we actually leverage the sentence-bursts and the GPT-3 ADA as our pre-training model. The goal of the project actually to create and fine-tune a multi-label classification head, as shown in the block diagram in the middle. The loss function we use is binary cross-entropy, just to make sure all these components are not impacting each other. Baseline is based off this sentence-burst with a single layer of MLP in our head. Is trained and validated against the S&P 500 data and tested against the actual company annual reports.
Yeah, so coming to our target models, we have 4 linear layers for our classification head. And for these linear layers have a leaky layer ReLU activation with Adam Optimizer. And one of our target models gets 768 embeddings from pre-trained BERT. And the second model, GPT-3, gets 1024 pre-trained embeddings from that. And we have tried with smaller classification heads, but the model wasn't able to generalize well with given data in hand. And we have tried various ways to train our model, but we found out that model which is trained on single label data first and then fine-tuned with hand label data has performed the best. And we have faced some challenges, so insufficient multi-label samples in the internet, and it is very hard to label them. And coming to the decision threshold, there are various decision thresholds for given data, given test data, and that comes up to the accuracy score calculation. So it is very hard to calculate accuracy on top of that. And here we can see the results for the sentence BERT. And here on the right side you can see the accuracy curve which is calculated on the soft condition. So the soft condition is basically the predicted is true when there are true labels in that, and more labels are acceptable too. So this is because the test data is manually labeled, so the model might pick up some hidden meanings and can produce some extra labels, so we don't want to ignore that completely. And here we can see the results for GPT-3, and it is not better than BERT. So we can see the hyperparameters on the top. And here we can see the quantitative results, comparison between the BERT and GPT-3. So these results are based on the hard condition. The predictor label should definitely match the true label, nothing more than that. So we can see based on the hard conditions also we are able to get good results and good F1 scores for each individual label, and when you average it out also we are getting a good score. And here we can see a simple UI which we have created for the user. So user input the text, and when we click on analyze button, so we have 3 graphs. So one graph is for first one is for the baseline model, and the second one is for the target model which is based on BERT, and the third one is based on the GPT-3. Here we can see we have provided user to set the threshold, and he can easily see what are the labels which he is getting. And coming to the results, we have observed that sentence BERT has performed better in quantitatively, but coming to qualitatively, based on our testing, we found GPT-3 has performed better qualitatively. So as it has less dramatic predictions.
Some learnings there. We discovered single labels actually quite helpful even for multi-label classification problem.
Pick the most important two.
Yeah, and then I guess talk about reflection. It is quite challenging. I think the team doing multi-label classification problems should research earlier on the different accuracy scores and actually make a decision on that based on your use cases. That concludes our presentation.
All right, thank you.